I'm Ethan Kwan, and today we're going to be talking about groups. Groups. Oops, nope. Groups. U-P-E-S. Groups. Or actually, there's no E in groups. Sorry. Groups. Anyway, sorry, I'm really bad at spelling. Anyway, so here's the periodic table, and we're going to be talking about the groups, the thing that had so much trouble spelling, groups of the periodic table. So what is even a group? Well, I guess you could view the groups as the columns of the periodic table. And like most things that we want to do, we normally number the columns 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Black is kind of a boring color. 14, 15, 16, 17, and 18. So that means there are 18 groups of the periodic table. Okay, so why do we even care about groups? Well, even though the atomic numbers are very different, here, let's zoom in on one of the groups. Let's say hydrogen here. So hydrogen is atomic number 1. You get that, right? And lithium is atomic number, lithium is atomic number 3. Sorry, I'm drawing with a mouse here, so that's why my drawings aren't too good, not using a tablet. Here's 11, sodium. Here's 19, potassium. Now, you may notice that all these numbers are very different from each other. Whoops. Is that good? Okay, anyway. So, you might notice that all these numbers are very different from each other. And that's okay. We don't care about the numbers. Really, we don't. Like, seriously. Okay, anyway, but we do care about each type of atom. So, each row has very similar properties as you go down because these atoms have very similar outer electron structures. Actually, they're exactly the same with the exception of helium, which has 2 electrons instead of 10. 8, sorry. Okay. I'll get to that in a little bit. So, what are the electrons that are happy? Now, happy is kind of a vague term, so we're going to define it. Happy, in this case of elements, is if you have your entire outer shell full. So which are the ones that have their outer shell full, aka it's happy? Well, obviously these are going to be the noble gases, and these are just perfect atoms with all their shells full. Let's do it in this color. Okay, so these noble gases here are happy, or have their shell full. Okay? Now let's go to row 17, right next to it. Let's look at fluorine. Fluorine is almost happy. It's so close to being happy, completely stable. Okay? So fluorine needs 1 electron to get to a stable state, right? So, and that's normally what you would get. You normally see fluorine with a -1 charge because, actually it would be written, it'd actually be written, it would actually be written 1 negative, so anyway. I'm going to change to a darker color so you can see that. Okay, so fluorine would normally have a -1 charge because everyone wants to be happy, right? Okay, so unless you're really grumpy, of course, then no, anyway, you can discuss for yourself and maybe even leave it in the comments below what you think is happy for humans. Anyway, if you are a human, of course. Okay, so for example, chlorine is also so close to being happy. So you'll normally see chlorine with a -1 charge. So same thing with oxygen. Oxygen you'll normally see with the -2 charge. Oops, no. That's a -1 charge. -2 charge because oxygen wants 2 electrons to become full, right? Now let's jump. So that was this extreme here, right? These guys here want electrons, right? Now let's look at the other extreme. This part. I'll just scroll over a little. Okay, so let's just get rid of that circle for now. Okay, so let's look at lithium. How does it how can it get to become a stable electron configuration fastest? Well, I guess if you wanted to, if it was hard, it's hard. So I guess you can make it so that it gets. Oops, nope. I guess you can make it so that it gains 7 electrons. So Li with a 7 negative charge. That is possible for lithium, but then it's really hard to do that. A not much easier way is if you look back, if you look at the atomic number, this is 3 and a noble gas behind it is 2, helium. So it's much easier for it to give an electron. Because if you imagine the periodic table wound up in a sort of spiral, so the numbers are listed 1, 2, so 1, 2, 3, 4, right? This is a noble gas, right? So, and lithium is this one, so you want to go back a step, right? And that's normally what you see. You normally see lithium with 1 plus charge because it lost an electron. Now it has an extra proton, which means it's +1. So normally you will see this happening. And same thing with potassium. Potassium, and partly I chose potassium because it's a pain to write Na, 2 letters, with a mouse. So you'll normally see potassium with a +1 charge. Same with calcium. Calcium, whoops, nope, that's the worst circle ever. Calcium, you'll normally see calcium with a +1 charge, right? So this is everything you see. And what do negatives and positives want to do with each other? Well, they want to attract each other, right? So normally you'll see bonds between these because, so this one, so calcium gives an electron to fluorine, and then they become +1 and -1, and so they bond because they're positive and negative, so you'll get CAF, right? Sometimes you'll get CAF, calcium fluoride, which is really interesting. You can get lithium fluoride, you can get sodium fluoride. Actually, let's write down sodium fluoride, NaF. Now, you don't always have to just go with fluorine. You can go with chlorine or bromine or iodine or anything here. And actually, even tellurium can bond with strontium because this one needs a +2 charge, and this one needs a -2 charge. So strontium gives 2 electrons to tellurium, and basically things happen. That's not the best way to describe it, but anyway. Okay, so what is the most popular bond? Well, you might be familiar with, well, here's sodium and here's chlorine. So what is NaCl? Oops, no, L. So what's NaCl? Well, you might know that as table salt. And table salt is a great example of, I can look it up if you want, if you're really You know, yes. Yes. There we go. Okay, anyway. Okay. Anyway, so that is how groups help us. Groups. Groups. That is how groups. Look at my bad writing. Groups. There used to be E there. Okay, anyway, thank you for watching. I hope you liked this video. If you did, please subscribe, like, and share the channel with others. Oops. Thank you for watching. I hope you liked this video. If you did, please share this channel with others. Subscribe, like, and share this channel with others. I already said share this channel with others a bunch of times. Okay, I hope you share this channel with others. See you at howtodosomething.com, and see you next time.